Good afternoon, and welcome to our third session of this six-part training on creating our Shiny applications and dashboards. I want to thank the Bureau of Justice Statistics for making this training possible. I also want to welcome back our presenter, Dr. Robert Ashmead. Dr. Robert Ashmead is a senior statistician at NORC at the University of Chicago. So without further delay, I will turn things over to Dr. Ashmead.
Thank you very much, Jason. Welcome back, everyone. Let me just share my screen. Okay, great. Um, Today we have an exciting a set of material for you all. We kind of start getting into the really fun stuff now that we've learned some of the basics. We're gonna use and learn about some of the interactive tools, tables, plots, and maps that we can build into our Shiny apps and dashboards. Um, just for just for everyone's information, we'll plan to be more around an hour today versus the hour and a half we have done for the last two sessions, just for your own planning. Um, so where we left off, well, I say first I should just have a reminder in case you weren't in one of the earlier sessions. Um, the materials are available on the GitHub site here, which was sent around in the email. And if you weren't in the earlier sessions, we're using a data source that is not part of the GitHub that you need to download separately. The instructions are in the slide 31 from session one, if you need that. Okay, so where we left things, we had just learned about this isolate function and kind of a compute button, action button that we had put in our example app. And I had left you all with some take-home activities, some ideas for some things you could try. So I wanted to start with that today. I want to bring up the version of the dashboard kind of where we left things last week. So I'll bring that up. All right, so we had these two pages for our new UI template. We had just implemented this update the plot, and we had talked about how we had implemented this isolate feature. So um, the plot doesn't update unless we press the button, but the table still does because we hadn't connected those two things yet. And we had put in some new ggplot features for the plot. So some of the things, some ideas for some things I said you could try. Adjust the UI layout to better place the table in the app. It's kind of was just hanging kind of in the middle here. If there's anything to be done there. Also, maybe adjust the colors of the background in our plot. A different visualization that makes sense to change to. And adjust the action button so that both the table and plot are only updated when it is clicked. So we use that isolate for one of the features, but we didn't do it for the other one. So I'll show you all what I did for my changes. So I actually wrote them down. We can go through them. Um, I adjusted the UI for the table output to be in its below the sidebar main panel. I adjusted that action button so the table and plot title, excuse me, are only updated when it is clicked. One extra thing I'll show you how to do in the version we have here. As I was working on this, I was becoming slightly annoyed just with the how this looked with the labeling of our variables here. You know, we have this nice prosecution grouping, prosecution offense, prosecution degree. over here on the left-hand side. But when we actually put them in the table in the plot, they kind of have these uglier variable names. So I'll show you a trick for how to give them kind of back their plot names or the same names we're using in the UI. Um, Adjusted the color palette on the plot and added a link to the data on the welcome page. We talked a little bit about, using HTML tags, and I'll just use that as an example of how to do that. So let's take a look at the updated version. I'm going to get rid of this one. So this is that run take home one .r in the new set of materials. And we can look at it and then look at the code. Okay, so the first thing you'll see here is I put this link. I didn't put anything too fancy up here on the front page, but just the data in this dashboard comes from the Florida Department of Law Enforcement website and just links to where we downloaded the data from. Always nice to put. So to do that, I use some of the things we learned about last week with the tags. So the first thing you'll see in this tab panel, welcome, I added this bit here with this H1 function from tags, which means header level 1. It just has some automatic formatting for that. And then the data in this dashboard comes from, no formatting there. And then this tags A is how you put a link. So you put the text that you want to be kind of linked, and then the reference, which is the actual website. This bit about the target equals blank just means it's going to open up a new page in your browser rather than changing the current page, so we don't accidentally leave our dashboard. So that's just an example of how you would use some of that HTML that we learned about there. Okay, so let's see what's next. Okay, so the other things I did, so we talked about cleaning up the isolate, update the plot and table option so that it only will update all of our materials when we click that. So to do that, what we needed to do was just continue with the isolate for both the table and the plot. So putting the isolate feature, we just kind of follow the same pattern as we did before. We put the input update button outside of the isolate in the server, and then all the material we want to not be affected, not to affect the changing of the render table inside that isolate. And I believe I did the same thing for this plot title as well. Yep, I stuck it all in this isolate. Um, the other thing, so now I have it so um, rather than seeing the name of the variable, which was kind of ugly, in this table, and the plot, and kind of the label here, I have the similarly the nicer names that we were using in the UI. And so how I accomplished that um, was, so here, let's see. So here's, for example, let's see, what's a good example of this? So let's go to our render table. Um, so here, where it says tab data names, what I did was in our global, we had defined this mapping between kind of the nice names for our outcomes and our grouping variables and the variable names. So I'm actually using this object inside my server. Um, so what I did is I said, I want to grab the names of the outcome variables. So this is outcome variables. This is the value. This is the name of that value. So this will grab the kind of the first thing there. And then I said, pick the one where the outcome the value of it is equal to the thing I selected from the input. Um, and similar thing for the grouping. And then I just rename my table output there. So I use the same trick kind of throughout. You could also imagine, we talked about reactives last week. One way you could use a reactive is rather than me doing this several places throughout this whole code, right? We could do this once, define a reactive that holds the name of it, and then just use that in the different places where we needed to use it. That would probably be a more streamlined way to do that. Um, Other things I did here. Um, this was a little bit of cheating how I said it in the prompt, but looking at things over years. So how I did that was I just actually added a variable to our grouping for the years, which sort of accomplishes that in a fairly easy way. So now what we can see is um, the number of the arrests kind of divided up by the different years in each of the categories. And I think that was the other thing. Um, oh, the UI. All I did for the UI, it didn't make a huge difference, but I broke in our data analysis, I put a fluid row that kind of encapsulated both um, kind of both the panel and the plot, and then a second fluid row that encapsulated the table that is around that part. The one thing about this table, the basic table output that we're using, it doesn't grow to fill the space like some of the what we're actually going to be using here and talking about in a second. So it does just end up back in the middle. So it's not quite as exciting there. And then the last thing I did was just adjust the color palette for our plots. I used this command scale fill brewer and picked a new color palette for our plots. So that was what I did for this one. I'm curious if anybody else took a try at things and wants to share any experiences or has any questions on the changes that we put in place there. Okay. The other thing I did have this other take-home assignment was to kind of play around with that alternative data set. I'm just going to let you all kind of use that as your own palette to try new things out rather than kind of going over that one as well, just for the sake of time. Um, so yeah, if you have questions or have want to something that you want to show coming from that to everyone, please feel free to let me know. Okay, any questions before we get into the content for today? Okay. Okay, so today we're going to be talking about interactive tables with a package called DT for data tables, interactive plots with a package called Plotly, and interactive maps with a package called Leaflet. And these are kind of my go-to in these areas. We'll talk at the end about some alternatives that are out there, but I think these are pretty simple to use compared to the alternatives. And yeah, they're my basic tools that I use. So these were included in kind of the overall instructions for the packages, but if you didn't happen to do that, please make sure to install these packages, capital DT, um, Plotly and Leaflet. And remember that you can always copy the code from these slides. Okay, so let's start with data tables or DT. So DT is a package that uses a JavaScript library called the data tables. I'm just going to open this up quickly. So what that means is this isn't a tool that's only available in R. This is a tool that works in a lot of different places and a lot of different settings. But what we have here is a package that kind of lets us plug into it. So this is something that's available, I think, generally in HTML. You could write it in straight HTML. I'm sure there's packages in Python and lots of different things to connect with it. So that means it has a lot of features, and kind of the way R works is it's bridging the way that you can use it. So you may encounter data tables already in your day-to-day work outside of R and R Shiny. And that's going to be kind of a theme for us today in terms of Plotly and Leaflet too. There are similar tools that work in a variety of languages and outside of R and Shiny. And why I like this is kind of right off the bat, we get really nice set of tools by default, a nice looking table with pretty minimal effort. So I'm going to copy this code and put it in R, but all I'm doing here is loading some libraries, and I'm just taking that iris data table, I'm picking a few variables, and all I'm saying is data table, and that's a function that comes from that uh, DT package. So let's swap on over to R here. And I'm just going to paste this in, and we'll make this bigger. So we'll just look at this in our studio for a moment. It has a nice viewer here for our HTML. So what we see here is our very first data table. This is an interactive table right off the bat. So this is just our iris data set. We see the variables that we selected up top. We can actually sort them right in this little JavaScript app. Um, you could subset or search. This is a little funky for numeric values, but if you had categorical values, it allows you to subset and find those actually in the table. We have some scrolling features. We have the data separated into different pages. All that and all we said was data table. So that's off the bat, some really nice, easy features and looks great. So that's one of the reasons why I really like this. We have to do pretty minimal things to get started with it. But there are a lot of extra options to make this look better. First thing we can do, we can turn on and off row names. We can add a caption for our overall table, and we can adjust the column names. So to do that, we see this row names equal false to turn off row names, caption, and then we can just give it alternative column names directly in it. So let's take a look at what that change does. So now, this overall name isn't too exciting, but it goes up there. And you can see we have nicer names for our variables here, and we no longer have that row names. All right, so the next thing to look at is what are called extensions. So there's lots of things built into the functionality here. So we've done our basic data table, we've adjusted the row names, the caption, the column names. Now I'm going to add this extensions called buttons, which is going to give me some other features. Um, and then within that, I'm going to put a list, which gives the options. Or as a second parameter, the options, I'm going to change the scroll behavior on both the X and the Y axis. So like vertically and horizontally. I can turn on or off paging, so how much shows up. And I'm going to add these default buttons here. CSV, Excel, PDF, and print. This is actually going to allow us to download the data that's in the data table directly in the little JavaScript app. And this this parameter here, DOM, these letters represent the order which the buttons show up. It's not super important to know, but kind of just have to have it in there. I can't remember off the top of my head um, what what each thing stands for. Um, but maybe the last one's printing. But let's take a look at what that looks like. All right, now what I get is these buttons here. I see you can see it CSV, Excel, PDF, print. So if I were to do that, I could actually download and look at these or get a PDF or an Excel, which is a really nice feature. It's a very common thing people ask for in dashboards, like, can I get the data? And there's more complicated ways we can build in downloads into our R but it's really nice to just have that functionality kind of built into the table for us. You can see now, rather than having a bunch of pages, we are able to scroll vertically all the way to the bottom. And yeah, and there's no X scroll here. So we're starting to turn into a pretty nice feature here. And there are even more things. We're not gonna go over all of them today, but another thing you can do is add an option to allow the user to hide or see columns. So this is this additional button we're gonna add in here called Colvis or column visibility. So just we can take a look at what that looks like. But so here we get an extra button here, and I can actually dynamically uh, show or hide different columns, which is really nice. You know, for example, you could use this. We don't have to start off showing all of the columns. Maybe you want to show kind of minimal information, but have the other columns there if the user wants to see it, but it kind of hide it away if it's not kind of critical to the app when you start. Okay, so this is just kind of a sampling of the data table extensions. There's so much stuff out there. There's ways to edit them in real time. There's colors that we can add to it. There's all kinds of different things if you kind of go through the data tables. Um, Functionality and documentation. So this is just a little bit of a taste of kind of the standard things that I typically create in my dashboards. So let's try out adding data tables to our app. Okay, so we're going to have kind of a theme today, and that is specific. We get for each of these packages, we're going to have a render DT, which is the piece that goes in our server, and we're going to have a DT output, a piece of specific function from the package that goes in our UI. So we're going to replace our kind of our basic table that we have in there for our example with one of these DT tables. An example one in our code. And the great thing about this is there's actually very little code that we need to change in this case. Um, and let me find my examples hiding behind here. Okay. So the big thing, this was our previous example. Okay, so basically all I had to do in our output table here is I swapped the render table for render DT, and then changed the output here to add this data table where I took our data. I'm actually going to I'm going to use the same plot title reactive for the caption there. Give it um, the data names where I've used that same trick we talked about with renaming things to give them that nicer names there. And then kind of add in those extensions and options we talked about there. So pretty minimal changes there. And then all I had to do in the UI was actually swap out my output function for this DT output. And otherwise, we're naming it the same things. Pretty simple changes there. So let's go ahead and take a look at what that looks like in an actual R Shiny app instead of just in our studio. So we go over to data analysis. Let's give it a slightly less ugly plot here. So you can see here, we didn't change the UI at all. I had said before that one thing I didn't like about the basic table is it didn't kind of expand to fill the space. This DT will expand to fill the space we give it. So you can see the table here. So we have that same functionality as we had in our studio. We can sort these things, rearrange them, search, change the column visibility, um, all those kind of good things. We can add this in here. And then we can also, that I think the download feature is really nice and helpful. I'll go ahead and download it here. You can see what this will open it up in. You can see our data there, um, and exactly as it is in the table. Opening it as a CSV here. I'm not quite sure what program this is on this Mac. Um, but yeah, that's a really nice feature and one that's, nice to have that built in. And that is the basic data table there. Any questions on that or the capabilities there? If you're interested in putting that in, like I said, there are lots of different additional options that you can use and implement. So highly recommend it. Okay, let's keep going into interactive plots. So here we're going to be using a package called Plotly. Similar to DT, Plotly is a way to connect R with this general Plotly graphics visualization library. We're going to use these functions render Plotly and Plotly output. The other nice thing about Plotly is that if we're coming from being used to using ggplot, but are new to Plotly, there's a function that translates ggplots to Plotly objects, and it is called ggplotly. So if we have a ggplot and we give it the function ggplotly, it can turn it into a Plotly object, which has the interactivity. So let's take a basic example of that. So I'm just going to take our arrest data from Florida. I'm going to count the cases by sex and prosecution level, and we're just going to do a little bar chart of that in um, ggplot. All right. So that kind of looks like that, basic ggplot, similar to what we've done before. But now, if I say, so P is my object here, if I say translate that to a Plotly object, I get a very similar looking plot, similar color, but now you can see kind of off the bat, it has built-in hover capabilities where I get these tooltips. I actually can turn on and off some of the aspects in the legend to the different plots. And you see all these features at the top. that are interactive features, I can actually download the plot as it looks like at a given time. I can zoom in, all those kinds of things. Um, and then the download the plot will make a PNG of it as it kind of is shown in your viewer. Um, there's all kinds of things about resizing it. I'm not even lasso select. I think it's more if we have individual points, zoom in and zoom out, auto scale, axes, all kinds of different stuff that are built-in features of this Plotly plot that we kind of get for free. So that's basic thing for changing it to Plotly. That works really well. So it's a good thing to start with if you're new to Plotly. We can also, uh, yeah, I see a question from Caitlin. Go ahead.
Just wondering, so your Plotly is like its own separate thing from Shiny then, so you're not even using it within the Shiny package?
Yeah, so we are going to be able to we are going to put it into to Shiny kind of at the end here, but for like demoing it, it also exists outside of Shiny. It's kind of an HTML based package, so you can use this with other things that are HTML based. And you can also use it outside of R. So there's connections with Python, and I think other languages as well, and definitely Python. Does that
That,
make sense?
yeah, is that the same for the DT package too? Like you can use that outside. Okay.
Correct. So if you're, we're going to talk I think the very last session that we're going to do, the sixth session, we're going to talk about kind of R Markdown and Quarto and making HTML reports. So all of these tools that we're learning with the DT and the leaflet and Plotly, we can actually use in those HTML outputs for those reports and make kind of interactivity, which is really cool because we can reuse these things in a bunch of different places.
Yeah, that's awesome. Thank you.
Yep, not a problem. Okay, so that is how we translate from ggplot to Plotly with that ggplotly. We can also write things kind of in native Plotly language. The main advantage of this is in writing it directly in the kind of the Plotly function and language is that you can better customize all the features that you want. You know, if you're just using the translation from ggplot to Plotly, some things are hard, a little bit more difficult to make exactly how you want them versus building it in directly in the Plotly language. So we're going to go through an example. We're going to kind of build the similar thing directly in Plotly. So the first thing I'm going to do, call the Plotly library. And then what I do is kind of similar to ggplot, where we started out with like a ggplot call, no matter what kind of output we were looking at. We're going to start off with this plot underscore Lee call, and then give it the data set that we want to use. And then how the syntax works here, or one way to use the syntax, is I can reference the variables in this data set by their variable names without quotes, but by using this kind of tilde to say what is a variable that is coming from this data set. So in the same thing here, use that same data set. I'm going to say our x-axis is the prosecution level, our y-axis were the counts. The grouping variable that we're going to actually use here is this split piece. So that's going to do the grouping, and then I just tell it it is a type bar. So let's take a look at what this looks like. Okay, so it looks a little bit different because Plotly has its own kind of color schemes by default, but it is the same information. By default here, even we're building it with the basic Plotly syntax. We just even have that one line of code, right? We still get all those nice basic Plotly features we were just talking about. We get this hover feature. It is automatically coloring it. We can download as a PNG. We can turn all these things on and off. Really nice kind of out of the box options here for us. So that's how we get started. Um, One big thing here, if you're going back and forth between ggplot and plotly, if you remember in ggplot, we strung everything together with these plus symbols, addition symbols for the different pieces of the layers. We have to remember that we don't do that for this particular package. We're going to use pipes in between the different parts. I will admit that I often forget that when going back and forth between the two, and often get an error in my code because I forget to transition those. All right, so there's lots of options that we can do similar to ggplot. So here was our basic Plotly line of code that we ran last time. And I'm just going to add a pipe, and then I'm going to say the layout. And in that layout function, I'm going to change the title. I'm going to change the x-axis and the y-axis. One particular thing to watch out for, just to be aware of with this Plotly, is it uses lists a lot when you call the function. So you actually say, here like x-axis equals a list, and then I'm changing the title of the x-axis in there. And the way that works is we're just using one argument here, but you can imagine that you could have lots of arguments within this list. Sometimes they even have lists within lists, but in this particular syntax, there's a lot of kind of parameters set it equal to the list, and then you have a bunch of things inside that. So let's take a quick look at this. Not too exciting, but we get our nicer X and Y axis titles and our overall title there. Okay, one thing that advantage of these Plotly graphics over kind of the base ggplot is we get those we can customize the tooltips. Now we got tooltips when we did the ggplotly, but from my experience, it can be difficult to customize what goes in the tooltips in that case. So this is one really nice thing. We can kind of add more information in your tooltips, and we can tell it how that happens. So there's several ways to actually do this to add tooltips. That kind of the most efficient or the most trustworthy way I like to do it is actually to make a new variable in the data set before we give it to Plotly, and then we basically tell Plotly that that is the hover information. So what I'm going to do is I'm actually in our table that we're making of the data before we were just counting by sex and prosecution level. Now I am adding a percent, but I'm adding this extra mutate here, which I'm calling the variable hover text. And then what I'm doing is I'm actually just pasting together a bunch of information drawn from the table that I want to show for each data point. So in the table, each row is actually going to be a data point, and then we're going to have an extra variable for it that is the hover that's going to go along with it. So this is going to kind of say, among male arrests, 15% are level first degree. The B here is HTML. We actually talked about this slightly before for bold. So this part's going to be bold. This is a symbol, HTML symbol for a line break. And then I'm going to say the count is the count, the whatever, 15 or whatever. And then this extra bit is just to, if you looked at our Plotly, the default tooltips that come out of it actually has like two spaces. One was a main color and one was white. I actually don't like how that looks, so I kind of just tell it to ignore the second part of it, so it just does the first part. And then all I have to do is when I am calling my Plotly, um, I say hover info equals text, And then I say the hover template is this hover text that's coming from the data to object, which we're saying here. And then this layout part is exactly the same as we did before. So let's do that quickly. So now what I get is this custom tooltip here. So among female arrests, among male arrests, it's highlighting that. So now we get not only the percent that's shown in the actual plot, but we have the count there to go along with it if the user needs additional information. So it's a nice way of being able to provide additional information when not showing it visually. So that is custom tooltips. Okay, so now we've kind of learned the basics of Plotly. Let's convert our plot in the dashboard to Plotly. Like I said before, we'll need this switch things out with render Plotly and the Plotly output. So let's take a look at example 2. Okay. So the thing I had to do in the UI, the only thing I really had to do is I had to change our output to this Plotly output. Other than that, exactly the same, which is very nice. There was more to do in the actual server. So now when we made our output, said we had to change this to a render Plotly. And now we had to change all that ggplot syntax to Plotly syntax. So the way I did that is actually it's fairly simple. We had these couple of options, these logic paths, based if I had grouping or no grouping. One thing that is different than our example is it's a little bit harder to kind of generically select variables. We had used that tilde and the name of the variable without quotes in there. Now we needed to kind of substitute in what was in our selection for our UI. And so the way I'm actually accomplishing that here, I'm saying a Plotly, I'm giving it the data here, which is this tab data. And then I'm using the trick that I'm calling the data set and then the double square brackets. And then the input as the variable name, so it will substitute in the variable to access it there. Same thing for the y-axis, and then my grouping variable, the split. I'll do that step, and then I'll give it the layout. I didn't put a custom tooltip in here, something you can practice if you would like to here. But that's all I have to do to switch it into being a Plotly table. So let's set working directory. Take a look at that. Okay, so now we have a Plotly table in our app. We get that tooltip. We can group, we can turn these things off just like we did in R Studio. The other nice thing here is, that built-in download feature. There is a way to actually control what the name of the file is when you download it, but just like downloading the data in the DT data table, having a way to capture the interactive image kind of built into it is a really nice out-of-the-box feature for dashboard builders, because usually this is a thing people always ask for, right? They're always like, make sure there's a way that I can get the plot and stick it in my PowerPoint or something along those lines. And there are ways to capture that and build the download button in our Shiny, but having it kind of right there for you built into it is a lot nicer than having to kind of engineer it yourself. And like I said, this will capture whatever changes. So like if I zoom in and I download it, it will give me exactly as it is zoomed in. I guess it moved the label there, but otherwise, a really nice feature there. Um, okay, so that is kind of the basics of Plotly. Um, there are kind of like DT. There's a lot more to it. It takes a lot of practice to learn all the different options. Um, but that's kind of like a little bit of the syntax to get you started. Any questions about Plotly? Okay. The last topic we're going to talk about today is interactive maps with Leaflet. So this is, I think, really cool. I am not a geographer or a GIS person by training, but I've picked a little bit of it up on the way. So Leaflet, similar to our other packages, JavaScript library, interactive maps, has this integration with R, but it can be used both outside of R Shiny, and I think it can connect to things like Python as well. One note here, um, Leaflet does need an internet connection to work. Not a problem for us today since we're all on Zoom. But in those examples where we talked about, for example, putting this in a HTML document for like Quattro and R Markdown, that gets a little bit more complicated. You have to make sure you have internet access in that case. So here's our little basic example. I'm just going to load the library. I'm going to call a leaflet, similar to kind of our other syntax. I'm going to add a base map with this add tiles, and then I'm going to add a marker on it. You can kind of maybe guess what's going to happen here with a latitude and a longitude. So if I just run that code, you can see what happens here is I actually get this interactive map. Hopefully I got this right. I looked up the address of JIRN and I get this nice little pop-up, a marker in the map. But you can see here, this is a scroll map that lets me zoom in and zoom out. Actually loads, very detailed information for our map there. So if you didn't know where the headquarters of JIRN are, that is a good marker. So that is a basic leaflet. Like all our other examples today, for use in R Shiny, we're going to have a specific render leaflet and a leaflet output. So same kind of pattern that we've been using all along. If you haven't worked with geographic map data before, one thing that you need that is a little bit different is you're working with these shape files, geographic information. So our example data set that we have been using has a variable in it called county, which we're going to use today, and to build an interactive map within our dashboard that tallies things by the county. However, first, what we need to do is actually need the county boundaries for Florida. There are a couple ways we could do this. If you go to the U.S. Census Bureau site, they have these tiger shape files. What I have found is that you actually have to download the county map, basically the files for the entire U.S. at once, which ends up being very large before you can subset it down. What is nicer, I have found, is there's a package in R called Tigris, which references those same tiger maps from the U.S. Census Bureau. And there's a package to actually download them specifically. So Florida's FIPS value is 12, and I'm going to download the 2024 version of the map. So this is just the package, calling this counties functions, and I'm naming it Florida Counties Geo. So we can do that quick. Okay, so we could look at that. So you can actually see it's downloading here. Does take a little bit of time to download. Um, but if you're not used to looking at those, this is what that shape file looks like. So how it's actually represented in R is actually not really pretty simple to work with. There's a row that represents each county, and then it has some information about it, some identifiers, its name, um, and then even the area of its land and water. Um, and then the last thing, it's kind of hidden here, but it actually stores the geometry, the full geometry of the county within this kind of database data set um, setup, which is nice because we're going to actually do some joins to be able to work with this pretty easily. So what we want to do now is incorporate this shapefile into our map. So what we're going to do, we can either make a map with kind of a base layer or not a base layer, which is kind of that default map that shows up. So if I want to use a kind of a more plain layer, there's this Esri world gray canvas. And then I'm going to tell it add polygons, and I'm going to give it the name of that data that we just downloaded, and then the label of the actual county. So we can see what this looks like. So now we have our map of Florida with its different counties. I get this hover feature. You can see here the shape files that we're actually using incorporate some of the water into them. We're not going to worry about that right now. If you were probably a better geographer than me, you would chop off the water parts of the counties in the shapefile. You'd probably also deal with this. There's a warning about projections, which we're not going to worry about as well. So, but we get a nice little map here with some hover capabilities for our Florida counties. We could do the same thing without the base layer, but we won't worry about that now. But what we want to do next is combine the map with our data. Um, and to do that, what we're going to first do is calculate the number of arrests per county. So that's just this little calculation here, group by county and count. And then what I'm going to do is I'm going to take our shapefile object and do a left join to the information matching the names of the county up. So a left join means everything in kind of our left data set that matches our right data set. Here, there should be a one-to-one, so it shouldn't really make a big difference. So if we do that, um, now if our joined object here, in addition to all the geographic information, we got this new column here that is the count, which was our count of arrests. And we'll be able to use that in our maps. So we can make a quantile map, which means we're just going to break the distribution up of our kind of continuous variable up into a couple sections, top 25%, middle quartile, those kinds of things. So to do that, we call leaflet, we can call our plane layer, we call our polygons, but just as we did before, but now what we do is we give it a couple extra variables. So we're gonna give it a color. This is just gonna control the shape around the boundaries. Um, the big thing here is the fill color. Um, so this is going to be the shade that it fills the county. And it's going to be, what we're doing is actually calling a function called color quantile. It's going to use this blues palette, and basically it's going to first derive um, a palette based off of the count, and then it's going to pull the right color for the count. So we can take a look at what that looks like. And ta-da, now we have a nice map with these different colored quantiles for the counts of arrests. We don't have a label here, which is a little bit annoying. We'll get that in a second, but that would be the quantile map. The other thing you can do is a continuous color map. This is a little bit trickier because we have to kind of define this color palette. Just for the sake of time, I'm not going to go into too much detail about how that's happening, but I'm first defining a color palette here, and then the only difference thing here is I'm using that color palette and pulling the color from it. So this will be our kind of continuous scale. And you can see here, there's just a few more shades of blue in between. The next thing, we want legends, make our maps a lot better. To do that, there is this add legend function uh, and we just say where it is, the palette, some information about the values, and we can see what that looks like. So now it's a little bit on top of it, but we can see there's four quantiles here, 0 to 25, 25 to 50, that match up with the number of arrests. Similar thing we can do with the continuous map. Hopefully this will make it a little bit more sense now. You can see now the colors representing a scale of how many arrests. I assume these match up pretty well with the populations of these different counties. So it might not be super exciting unless we standardize by the county population, but you can kind of get a general sense of the counties with more or less arrests there. Okay, so we can add this to our app. We're going to use render leaflet and um, add the map feature. And I'm not sure. I apologize for, I'm not sure what happened to my text in here. Um, we'll show the total counts of arrests on a new page in our app, and an option to do the prosecution degree. There's actually several things we need to do here to make this work. First, load the map data, set up the new UI since we're using a new page here, and then adjust the server code. And I'll show you how to do that. The first thing we're going to do is in global is load the county shapefile. So here I'm just going to use that code from Tigris where I'm pulling in the Florida counties. And then I'm going to define this object here, which is going to be our selection for our UI, which is the different outcomes we want to be able to do. So total arrests, first degree, second degree, third degree, capital, and life. Then I'm going to set up a new UI. So we're actually want to make this I'm going to make this a new page in our dashboard. So to do that, we added a new tab panel. And then within that, we're going to kind of use the same setup. The big thing with a date range and an outcome and an action button, similar setup to what we've been doing on the other pages. The big thing here I want to point out, the input IDs here have to be unique across all the pieces of the dashboard. So we already had something in our server or our UI before called date range. So all I did was add an underscore map to it to get a unique name. Otherwise, they would kind of collide and wouldn't work properly if you're giving the things the same name in different places. So you can see here, my input IDs just have an underscore map in each case to differentiate between what's in our table and plot page versus what is in our map page. So that was our new UI. Then in our server, we're going to set this up pretty similarly how we did it before. I'm actually going to first make a reactive of the data that kind of creates the data set that we want to do. We're going to filter by the arrest dates, group by county, and then calculate the number of total arrests, and then by each of these categories of the prosecution degree. Then we'll join that data to our shape file by the counties. And then in the map, we'll output the map. We'll use our render leaflet. We're going to isolate and use an action button here. And then kind of our similar code here as we had before. Let's see if it'll let me scroll over. The big thing here was we basically need to replace our variable names with these input options instead, because so we can have dynamic selection of variables here. But otherwise, this code is pretty much the same as our last example. So the big thing, is that dynamic selection of the variable here. And so this is again using that trick where map data is the actual data set, and then I'm using this double square brackets and putting the variable name at using this input, the outcome for the map. So let's pull this all together and look at it quickly. I was actually downloading the geographic data anew there. So now you can see here we added a new page to our dashboard. And now we get our leaflet map. We have our hover. I've made this the continuous style of map. I kind of prefer that. We can zoom in and zoom out, though there's not anything too interesting when we zoom out. And we can change this by the different variables: first degree, second degree, third degree, so forth. And there is ways we could, maybe you can customize the hover here. You could put the actual counts within the hover if you wanted as well. There's lots of customizations we can make with this as well. So a lot is out there. Okay. So let's review. So we talked about interactive tables, plots, and maps to add to our dashboard. I think this is where things get, as I said, a lot more exciting. These all kind of followed a little bit of the same pattern in that they're tools that can be used outside of R and outside of R Shiny, but kind of there's these plugins with R which we can use them. There are a lot of different options with these tools, so it'll take practice to use, but I think this is where you can really make your dashboard shine is by using these, and some of the basic options aren't too difficult to use. These aren't the only things you can use, but they are kind of easier to use in my opinion. But if you're looking for some alternatives, there are HTML tables. There's a package in R called React Table that is an alternative to the DT package. For maps and plots, there is something called D3, which is again outside of R, which is a package for visualizations. There's an interface to use that with R called RTU D3, which is pretty fun. But I'll note for this, the syntax for using the visualizations here, I think is a lot more difficult to use. And I actually don't know how to use D3 myself, but I know you can make some really cool looking stuff. It's just difficult to use. Similarly, there's a package called HighCharter, which I think in some cases actually you need a paid service, but it also allows you to make interactive and HTML maps and plots. We can actually also use Plotly to make maps in addition to Leaflet, but I tend to prefer the options in Leaflet personally. So, um, I do have some take-home activities for you here if you're interested in trying out these tools. The first one is kind of like a general challenge, kind of pulling together a lot of the things we've learned in our dashboard. Um, like I was kind of saying, our map calculations don't take into account the actual population size of the different counties. So comparing the number of arrests in the different places is probably not the best comparison because you were not standardizing by the county populations. So my challenge would be to like find a source for the county populations, see if you can pull that into the dashboard, and then use it as a denominator in the calculations with an option to turn it on and off to toggle it. The other thing you could do in our other data set for the NIJ's recidivism challenge data, there is also a geographic variable for the PUMA, um, uh, which is smaller, generally smaller than a county. Well, I guess it depends. But an alternative geographic area. So another thing you could do is take that data set and make a map there as well. Okay, I apologize for being a little bit longer than the hour I had planned, but I know the invitation said an hour and a half, so probably not the worst thing. Um, I'll open it up for questions for now, but what we'll be talking about next week is kind of a little bit moving about how to both host your dashboard. So, we've built these things locally. How would you share those with your colleagues or other people that you want to have access to them that don't necessarily need our skills? We're going to talk a little bit about accessibility, so some options we can build into our dashboards to make them more accessible. And then the last thing is a little bit of an advanced topic. We're going to talk about dynamic UI elements. So everything we've done up to this point, like our drop downs, it's fixed when the dashboard starts. So the options to select are never don't ever change depending on other options. So we're gonna show how to make actually dynamic UI elements. So if I have a drop down, I select one thing, maybe a different UI element pops up as a result. This is going to be helpful for us as we go into the session 5 when we actually talk about some dashboard security and password protection and authentication. It will help build a base for some things we need to do there. So thank you all very much. Any questions for today?
I could actually have a question.
Sure.
And it's probably a dumb question, but when you added the map to the dashboard, were you just like adding on to everything that you already had? So it's not like an actual like separate UI, like it's all within like the same UI file that you're adding into?
Yes, exactly correct. Let me open that up. So if we look at the UI, so this is where the UI starts getting pretty big. So this is the UI that we had. So we had the same things as before. We have this tab panel that defines, each of those defines the individual page. So we had tab panel for welcome, this tab panel for data analysis, and then this tab panel for map. So all we did was kind of, instead of end things here, we just added this in there and close it. So you can imagine if you start building a big dashboard, these files start getting very large. There are some strategies to kind of separate them out, but you just kind of have to also have helps to document things well.
So is there like a limit on like how many tabs you can have, or can you essentially like create tabs?
I don't know that there's a limit. Visually,
want a lot, but I'm just curious because I see how like so for like each separate page of the dashboard, you're having a whole separate tab within your
Mhm.
UI.
Correct.
Okay.
Yeah, so there are ways to kind of split things up into different files to organize things better. But yeah, so each of these is a different tab, and then there's different elements of the server that speak to it too. Technically, you could build something the way that this is set up, where I could change something on this tab and it would affect what happens on this tab. They're actually interconnected into the server currently. Um, but the way we're using it is everything's kind of in its own page. I think if you fill this up or make them extra long, it like gives you a menu where it's more like a drop down here instead of having tabs. Like if this took up too much space, I don't know if it'll happen here. Well, sort of.
Okay. Oh, I got you. Yeah, so this is gonna drop down. So not saying I want to create a dashboard like that. I'm just wondering.
Yeah, no, good question. Thank you.
Thank you. Helpful.
Anybody else questions? Okay. Thank you all very much. Hopefully, see you all next week to talk about hosting. So strategies for you all to share them. And feel free to get in touch with me between the week if you have questions about anything we've done here today or are trying out some of those assignments and wanna talk through something.